Hey class, I just wanted to do these last couple examples of finding the domain, not using a graph, but just using our rules, which are that we can't divide by 0, you can't take the square root of a negative number, and we can't take the logarithm of a negative number or 0. So when I have the natural log of some stuff, I'm just going to say that that stuff has to be greater than 0. Now, the nice thing about this is x to the fourth plus 9x cubed plus 14x squared is kind of like a polynomial. In fact, it is a polynomial. So if I'm trying to see where this is greater than 0, I'm just trying to kind of see where the function is above the x-axis. So I think about the graph of it. I'm not going to graph it, but I'm going to kind of treat it the same sort of way. So I'm going to factor because I'm going to find the x-intercepts. So if I factor in x squared, most of x squared plus 9x plus 14. And then x squared plus 9x plus 14 factors as x plus 7 times x plus 2. So the places where this would equal 0 are x equal to 0, x equal to negative 7, x equal to negative 2. I'm going to put those on the number line. And then I'm going to determine whether each separate interval is positive or negative. So I'm going to pick something like 2 and plug it in. 2 squared is positive, 2 plus 7 is positive, 2 plus 2 is positive, and a positive times a positive times a positive is positive. And then you can either say 0 comes from this factor with an even multiplicity, so the sign is going to stay the same. It's going to bounce, right? The graph would kind of, well, I'll do the graph at the end, right? It's not really the graph. Or you can plug in something like -1 and say it's positive, positive, positive. And then -2, which came from this factor with an odd multiplicity, it's going to cross from positive to negative. Or you can plug in something like -4, and -4 squared is positive 16. -4 plus 7 is positive. -4 plus 2 is negative. And a positive times a negative is negative overall. And then finally, let's pick something less than -7, like -8. -8 squared is positive 64. -8 plus 7 is negative. -8 plus 2 is negative. And a positive times a negative is positive. Or you could have said -7 comes from this factor with a non-multiplicity, so we're going to cross. And you can see that if you graph just this, which I know is not the function we're actually thinking about, but if you graph just this polynomial, you go positive, 0, negative, back to positive, back to positive. All I really care about the fact is that in these sections here, from all the way to the left to -7, and from -2 to 0, and from 0 to all the way to the right, this expression is positive. That's going to be my domain. So my domain is where x squared times x plus 7 times x plus 2 is strictly greater than 0. Notably, we're not going to include any of these points because if x were equal to -7, you'd have 0 here, and 0 times anything is 0, but we don't want it to equal 0. We want it to be bigger than 0. So we want everything here, everything here, everything here. So we want everything from -infinity up to -7, excluding -7, union. We don't want any of this because that's where it's negative, right? If x was like -4, I don't want that because that's going to make the whole thing negative. If everything between -2 and 0, but I don't want 0, so I'm going to go everything parentheses -2 to 0. I also don't want -2, that's why I'm using parentheses. And the last section here is going to be from everything from 0 to infinity. I'll just point out, because I do think it's worth pointing out, if the function were instead g of x equal to the square root of x to the fourth plus 9x cubed plus 14x squared, it would be almost the same answer, except, let me zoom in a little bit here. It'd be almost the same answer, except that now we would be saying that we want everything to be greater than or equal to 0 if it was this red function here. And we would include these endpoints. And if that was the question, the way we'd write the answer would be that the domain would be everything from -infinity to -7, inclusive of -7. Oops, sorry, -infinity. That's terrible, sorry. That's not so terrible, I guess. That looks like negative infinity. Sure, negative infinity. Sorry, that's kind of terrible. I apologize. -infinity to -7 with a bracket because I want to include the -7 now because it's okay for this to be equal to 0. We want the inside equal to 0. Union, everything from -2 inclusive. And then I want everything from -2 to 0 and from 0 to infinity, but I want to include 0. So I really should just go everywhere from -2, right? There's no breaks from -2 onwards. I'm going to go -2 to infinity. And that would be the domain if the function was g of x equal to the square root of x to the 4th plus 9x cubed plus 14x squared, because it's okay for the inside part, the argument, to equal 0. Whereas for this function, it's not okay for the inside part to equal 0. So we exclude those points that make it equal to 0. I should say make the inside equal to 0.